Hey everybody, Mr. Mack here. Today we're going to look at a factoring review, and we have multiple sections here, but we're going to be looking at factoring polynomials, and for the first one, doing it by finding the greatest common factor. So let's start with the even ones here, and I'll have you guys look at the odd ones on your own. What is the greatest common factor of 9 and 3? Well, that would be 3, and then we look at the x term, so if I have an x squared and an x, my greatest common factor for this would be 3x, and I would take that out of 9x squared, and that would give me 3x, and if I take that out of 3x, I get minus 1. So there we go. Now, as a check, if I were to distribute this again, I should get the original polynomial here. So 3x times 3x would be 9x squared. 3x times negative 1 is minus 3x. And yes, that is true. So that is my factored expression. All right, let's take a look at number 4. 27y cubed plus 18y squared. So I've got two coefficients here, and 27 and 18 have a common factor of 9. Now, if you're not quite sure what the common factor is here with our coefficients, you can always make a factor tree. So here's my factor tree for 27, a prime. And my prime numbers here on the left, my factors 3 and 9, and then 9 is 3 and 3. So here are my factors of 27, and then if I do 18, I've got 3 and 6, and I could do 3 and 2, and you could see here are my factors here. So my common factors are 3, 3 and 3, 3 and 3, so that's 9. So this would leave me, this is 27 is 9 times 3, and 18 is 9 times 2. So I can take a 9 out, and I could take a y squared out, because I have a y squared right here and a y cubed, so my maximum factor there is y squared, and that leaves me with 3y plus 2. And again, if we were to distribute this, we should get the original expression, which we do. Okay. So I'll do one more here on this section. We've got 4b cubed plus 2b squared plus 8b. And so each term has a b in it, and the coefficients here, 4, 2, and 8, are all even numbers, so that means 2 comes out. So 2 is the greatest common factor here with the b. So 2b comes out. And what's left? So if I take a 2b out of 4b cubed, that is 2b squared plus b. As I take a 2 out and a b out, it leaves me with just b, and plus 4. Let's just check that. So 2b times 2b squared is 4b cubed. 2b times b is 2b squared, and 2b times 4 is 8b. Okay, well, I hope everybody be okay with that. Yeah. Okay, so factor each expression by factoring out the greatest common factor. Okay, so this is going to be helpful when we look at grouping trinomials in a bit. So I've got x times the quantity of x plus 2, 7 times the quantity of x plus 2. So remember, x is multiplying here, this quantity, and 7 is multiplying here. So that means that I could factor out an x plus 2 from x and 7, and that would leave me with an x. So if I take out an x plus 2, that leaves me with just the x, and then I get a 7 for this expression. And that's it. Okay? Let's have a look at the next one here. Okay, so I've got, I have 4x times this quantity and a negative 2 times this quantity. Well, these two quantities are the same. We could factor out an x minus 3y, and that leaves me with a 4x minus 2. So let's have a look. So x minus 3y, nothing factors more from that, but I have a 4x and a minus 2. We could take out a 2 here. So I could, how about let's rewrite this. So I'm going to switch these two quantities. I could do that. And now how about we factor out a 2, because 2 is the greatest common factor of this expression. So 2 comes out, and that leaves me with 2x, and a 2 out of negative 2 is a minus 1. And then I've got x minus 3y. Okay, so that's my fully factored expression, and let's move on. Wow, okay, so now let's take a look at factoring trinomials. Okay, so we're in the form of x squared plus bx plus c, where our coefficient here in front of x squared is 1. So this makes it a little bit easier for us at first. So let's look at number 2 right here in this next section. X squared plus 14x plus 24. So when we multiplied binomials together, we used FOIL, right? And so if I had x plus 2 times x plus 3, we did the first term, we did the outer terms, the inner terms, and the last term. And so the first term, x times x, gave us x squared. So here's an x squared right here. So we're expecting that in our binomial, which is, we're going to get two binomials here when we factor a trinomial, we expect this first term again to be x and x. This last term is going to, in this case right here, 2 times 3 is 6. We expect the 6 to be our last term in the expression. So I have x squared was my first, and my last term is the 6. So 24, two numbers that multiply to give me 24. So I'm looking for the factors of 24 right here. But then if we look at our FOIL, the O and the I, in this case, is going to be 2x. So I'm going to have a 2, so outer actually is going to be x times 3 is going to be 3x, and my inner here would be 2x, and it gives me a like term combination here of 5x. So 5x is the addition of 2 and 3, right? 3 and 2 is 5. That's where we get our middle term. So 14 here is the addition of two numbers. And so we have to look for the factors of 24. Factors of 24, so factors of two numbers that multiply to give us 24 that are going to add to 14. Add up to 14. So, what are the factors of 24? So 1 and 24, and 2 and 12. We have 3 and 8. We have 4 and 6. And that's it, right? So which one of these adds up to be 14? Well, 1 plus 24 is 25. That didn't work. 2 plus 12 is 14. Oh yeah, that's it. So 3 and 8 is 11, and 4 and 6 is 10. So we see that this is what we want right there. So this is going to be x plus 2 and x plus 12. And then if we were to FOIL this as a check, we would see we get x squared. That's our first. Outer is 12x. Our inner is 2x, and our last term is 24, and then we see that 12x plus 2x is 14x, and we see that is the original trinomial that we were given. So this was correctly factored. Okay, that's number 2. Let's have a look at number 4. If you feel these are pretty easy and you got them, take a look at the next one, because they increasingly get a little bit more challenging. All right, so we're going to have 2 binomials here where we have x terms as our first, and then we need to figure out the factors. Now this time it's negative, okay? So we've got a factor of negative 9, and they add to negative 8. So because it's a negative number, it means we have to have a positive number and a negative number as the factors, right? They add to negative 8. So what are the factors of negative 9? So we have 1 and negative 9. We have negative 1 and positive 9. And we've got 3 and negative 3. That's it, isn't it? I mean, we could do negative 3 and positive 3, but that's the same as this one. And so these are the only possible factors of negative 9. So if we do 1 minus 9, that's negative 8. Well, that worked, didn't it? Negative 1 plus 9 is a positive 8. That doesn't work. And 3 and a negative 3 is 0. That's not good. So we got it. We need a 1 and a negative 1. So this is going to be x plus 1, x minus 9. And if we FOIL this, we will see that we get our middle term is negative 8. And our last term here is negative 9. It's going to work. Okay. Let's take a look at, I'll do 6. So we have we need to find the factors of negative 36 that are going to add to 5. So we know if our first term is x and x, and so the factors of negative 36, so this is a negative number and the middle term here is positive. So that means that I'm going to have 2 numbers, and one number's got to be bigger. The larger number, positive number, has to be larger than the negative number. So for instance, 36 and negative 1 would give me a positive number when I add, whereas if I switch this, negative 36 and a plus 1, that's a negative 35, and we're not looking for negative numbers here for our middle terms because it's got to be positive. So I mean, we can think about that to help us narrow down our options. So this one doesn't work. So what are the other factors? So is negative 2 a factor of negative 36? Yes, that's 18. 18 times negative 2 is negative 36. But 18 minus 2 is 16, so that doesn't work. So is negative 3 a factor of negative 36? It is. It goes in 12 times. 12 minus 3 is 9. That didn't work. So let's keep going. Negative is negative 4 factor? Yes. 9 times 4 is 36. So positive 9 times a negative 4 would be negative 36. If I add these together, I get 5. This is what we want. These are the 2 numbers that we want to use. So we get plus 9 and minus 4. By the way, it doesn't matter the order. If I want to say the negative first, minus 4 and plus 9, that's also fine. I could do that. We could FOIL this and check it, and it will work. Okay, so I have a bunch here from this section. This is kind of the meat of it, right? Factoring trinomials with the leading term being 1 the leading coefficient on the x squared being 1. So how about, I think we should look at the next one here. And we can undo a couple more. Okay, factoring binomials that are difference of two perfect squares. Okay, so what are perfect squares? So a number times a number will yield, a number times that same number will give us another number that's a perfect square. So for instance, 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. Because when I take the square root of these numbers, I get 2 and 3 in this case. So when I take the square root of a number, I get an integer. Okay, I don't get a decimal. So 4, 9, 16, 25, 36, 49. These are all perfect squares. Also, x squared is a perfect square. So x squared is a perfect square, because when I take the square root of x squared, I get x. Okay, so perfect squares, and they need to be the difference. So the difference means subtract, right? So let's take a look at a squared minus 121. Okay, so let's think about this in terms of the problem that we just had. We had x squared, we had plus bx plus c. This was our form of our trinomial. So in this case, we've got an x squared term, which is a squared, and we have a c term, which is our constant, is negative 121. And there is no middle term here, so that means that the b is 0. So what are we saying here? We're saying the factors, and this is always true when we have a difference of two perfect squares, the factors of negative 121 that add to 0. So in order for two numbers to add up to be 0, one has to be some number, and we're adding a negative of that same number. So what are the factors of 121? Well, 121 is 11. So what we have here is we have a positive 11 and we have a negative 11 to give us a negative 121, and these add up to 0. So my solution is a plus 11 and a minus 11. So the square root of a squared is a, and the square root of 121 is 11. But of course it's a negative, so one's got to be positive, one's got to be negative. Okay, so let's take a look at number 4. 9x squared minus 144. Okay, so these are both perfect squares. 9's a perfect square, x squared's a perfect square, 144 is a perfect square. So we're looking for the two numbers that multiply to give me 9x squared that are the same number. So that's 3x and 3x. And we're looking for two numbers that are the same that multiply to give me 144, except one's positive and one's the negative of the other. So 12 and a negative 12. And of course, when we add 12 plus a negative 12, we get 0, right? Because the middle term is not there, right? It's 0 times x. That b value is 0. So we get plus 12 here and minus 12 here, and that's our solution. And perhaps maybe on this one, I should let's go ahead and distribute this. Let's FOIL this, and then so you can see. So as a check, let's FOIL. So this 3x times 3x is 9x squared. The outer 3x times negative 12 is negative 36x. 12 times 3x is positive 36x. And a 12 times a negative 12, that's our last term. So we got O and I here. Last is negative 144. And then let's add these like terms together. Do you see? This is 0. Negative 36x plus 36x, that's 0. So we get 9x squared minus 144. Okay? So this was correct. Very good. Let's move on. And so this next one right here, section, we're factoring completely. So completely usually means that there's more than one step to factoring. We do one thing and then check it again and say, oh wait, we can still factor more out of this. Let's have a look at, let's do number 4. I want you guys to have an opportunity to look at 2 on your own, because that's kind of a cool one. So let's look at number 4 for this one, and then we'll look at the next section. Okay, n to the 4th minus 2n to the 3rd minus 3n squared. So for our coefficients, 1, 2, and 3, there's no greatest common factor for the coefficients here. But the n terms there is. I can take out a maximum of n to the 2nd out of this trinomial. So if I take n to the 2nd out of n to the 4th, that gives me n to the 2nd. If I take n to the 2nd out of negative 2n to the 3rd, that leaves me with negative 2n. If I take an n squared out of negative 3n squared, that leaves me with minus 3. Okay? So there we are. So I factored out the greatest common factor first. So I did the GCF first. You should always look for the greatest common factor of any type of these problems, because you're going to make things a lot easier on yourself if you do that. And easy is always better. So now we have this trinomial, and we want to look at it and we want to think, can this be further factorable? And it can. We can now take the n squared still over here, but now we can take this trinomial and break it down into 2 binomials. So we're thinking first term here has to give us n squared. So that's going to be n, and n give us our first term of n squared. Our last term right here is negative 3. So we're thinking, okay, well, what are the factors of negative 3 that add to negative 2? And I hope you see this is a fairly easy one, right? Because one has to be negative and one has to be positive. And 3 is already a prime number, so 3 only has two factors. It's 1 in itself. So we have a 1 and a 3, but 1's got to be negative. So if I make 1 negative and I add that, I get 2. That doesn't work. So let's make the 3 negative. When I add 1 and negative 3, I get negative 2, and that's what we wanted here. So that means we've got n plus 1 and n minus 3. And now this is fully factored. Very good. We can do 6. We'll do 6. Okay, so I have a negative x cubed and I have a plus 4x. Let's take out, so I don't like having a negative term first. So let's take out a negative x, because there's x in both of these terms. That means we can take 1 out. So if I take a negative x out of negative x cubed, that's going to give me a positive x squared. If I take a negative x out of a positive 4x, that's going to give me a negative 4. I mean, we check that real quick. A negative x times x squared is negative x cubed. A negative x times a negative 4, so a negative and a negative here, gives me a positive 4x. Okay, so that's going to work. But, so we look at this and we say, okay, this quantity, can it be further factorable? Yes, because it is the difference of two perfect squares, right? And that we just did that section. So I'm going to write my negative x here, and I'm going to write two quantities here, and I know I'm going to have an x and an x. And okay, so 4 is a perfect square. So what are the factors of a negative 4? Well, it would be a plus 2 and a minus 2. And remember, so the factors of 4 here, of negative 4, are negative 1 and 4, negative 2 and 2, and positive 1 and negative 4. But we need to add to get 0. So this doesn't work. The first two here don't work. Okay, only the second one, a negative 2 and a plus 2, give me 0. So it's the difference of two perfect squares. This is correct. Okay, moving along, and now we get to, so this next section is probably where we need to spend the most time. Factoring trinomials when our leading coefficient here, a, is not 1. So we can see in all these problems our leading coefficient isn't 1, and we can also see that we can't factor out anything more easily here to get the leading coefficient to be 1. There's just nothing that factors. So let's take a look at number, I think I want to do number 1 for this one. Okay, so I've got 3n squared plus 7n minus 20. And so what we're going to do here is we are going to, okay, so let's have a look at this very last section here. And we are factoring trinomials when our leading coefficient here, a, in the form of ax squared plus bx plus c, is not 1. So we have a couple more things to consider here. So let's take a look at 2, and then we'll do 6. So we still need to take the factors of a number that add up to give us this middle number. But the factors that we're going to need to do are going to be the factors of whatever a times b, or a times c is. So in this case we have to multiply 2 times 3. Okay, so 2 times 3 is 6. So we have to find the factors. Let's zoom in here. We have to find the factors of 6, because that's 2 times 3, that add to still our middle term here of b, a 7. So in general with these problems we're going to take the factors of a times c that are going to add to our b term when we have the form of ax squared plus bx plus c. Okay? So how about we get rid of this? Right. So what are the factors of 6 that add up to 7? Well, 1 and 6, right? We have 1 and 6, 2 and 3, and that's it. So it's 1 and 6 that add up to 7. So this is what we're going to do now. We're just going to rewrite this. 2x squared plus, now 1x plus, do I like 1x? Let's do 1x plus 6x plus 3 is this trinomial just rewritten, but I've broken up the 7x into a 1x and a 6x because those are the two factors that we saw that worked. 1 and 6 give us 7. There we go. So now, I need more space. Now what we're going to do is just going to take that and just drag it down a little bit. Now let's take we're going to now factor by grouping. Okay, so we're going to factor by grouping, and we did this earlier in the previous section. Let's take a look at the first two terms here, and then we'll look at the second two terms, and we're going to factor the greatest common factor from each grouping. So if we look, maybe I can even just think about this, and yeah, I like that. So 2x squared and 1x. What is the greatest common factor? X is the greatest common factor. So if I take x out of 2x squared, I get 2x, plus if I take an x out of 1x, I get 1. Okay, that's that one. Now let's take the next two terms. What is the greatest common factor of 6x and 3? I hope you see it is 3. So if I take a 3 out of 6x, I get 2x. If I take a 3 out of 3, I get 1. Alright, now take a look at this quantity here. They're the same for both this term and this term. So that means we can factor it out. 2x plus 1 comes out of this term x times, right? If I factor out 2x plus 1 out of x times 2x plus 1, I'm just left with x. And if I factor out a 2x plus 1 from this, I get 3. Okay, so that's it. That is my completely factored trinomial. And if I were to FOIL this, we will see that we get the original trinomial. I might do it. 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is 1x. And 1 times 3 is 3. And then I have like terms here. I get 2x squared plus 7x plus 3. And that is the original trinomial. So this worked. Here's our answer. Okay. Let's have a look at number 6. And this is our last one. So I have 4x squared minus 3x minus 10. I mean, first thing we want to do is are there any factors from these three terms that can come out? There are not. So we are going to factor by grouping. So what we want to do is we want to find the factors of a times c that add to b. So this is my a term here, the 4. My 10 is the c term, and the 3 is the b term. So I need to multiply 4 times 10. 4 times negative 10 is negative 40. So I'm looking for the factors of negative 40 that are going to add to negative 3. Okay, so negative 40, 1 and negative 40, that's you know, not even close, obviously, right? So 2 and negative 20, that gives me negative 18. I'm getting closer, but still it's pretty far. Negative 4 and 10 gives me, let's do a positive 4 and negative 10. Positive 4 and a negative 10. That gives me negative 6. I'm getting super close now. And so 5 and negative 8 are factors of negative 40. And when I add that, I get negative 3. So that's it. So what we're going to do now is we're going to, how about I'll put this over here on the right so we can have more space here. So now what I'm going to do is I'm going to rewrite, let's do it in red. Let's rewrite the trinomial. But instead of saying negative 3x, I'm going to just break it up to plus 5x minus 8x. Because 5x minus 8x is negative 3x, right? And those are the factors that gave me what I needed for my final term here. So now we have these two terms and these two terms, and now we're going to find the greatest common factor for the terms in these groups. So 4x squared and 5x, my greatest common factor is x. So that gives me 4x plus 5. And now I'll look at the next term right here. Okay, so I've got a negative 8x and a negative 10. I want to take out a negative, what am I going to take out here? 2. A 2 comes out of 8 and 10, so I'm going to take a negative 2 out here. And that gives a negative 2 out of negative 8x is a positive 4x. A negative 2 out of negative 10 is going to be a plus 5. Now notice these quantities are the same. We need that. We're really looking for that. And so that it'll happen as long as we do it correctly for these. And now I can factor out these two common binomials here. If I factor out the 4x plus 5 out of this first term here, I get x, and then out of this one I get a negative 2. And that is it. This is my factored expression, and see, nothing else comes out of any one of these, so that's it. Just to prove it works, let's check it with FOIL. So let's do first 4x squared outer, negative 8x inner, plus 5x last, minus 10. Add the like terms. 4x squared minus 3x minus 10. That worked. So this was the correct solution. I'll put another check here. Okay, very good. Take a crack at these. They definitely get more challenging as you progress through it, but then you're going to be expert students in factoring. All right, hope that makes sense. See y'all later. Mac out.